Well, good morning, everybody, and welcome to our presentation called SolidWorks in the Real World, talking about education and industry, preparing graduates to be productive right off the bat. Meet the presenters. My name is Gary Mascadrelli. I'm a professor and department chair at Springfield Technical Community College. Our program is Mechanical Engineering Technology. I'm a mechanical engineer by background. I worked 13 years in industry. Then a company I was working for went out of business. A friend of mine had started teaching at the college and said, hey, this might be something you'd like. There's an opening for mechanical. So I said, what the heck? I took the interview. They made me the offer, and I ended up taking it, saying, I'll do this for a couple of years. And 25 years later, here I am. So, and my partner is John. I'll let John introduce himself.
Hey everybody, I really liked the general session this morning. Yeah, good. See Marie Blanchard out there. I'm assuming a lot of people are from educational in here. So I've known Marie Blanchard for a long time, and this is Gary's first year here. So my background, being a SolidWorks user group leader, I've been in the community for a little while. Been using SolidWorks for a long time, since 1996, and just kind of been going to the Worlds for the last 4 years. But this year I found out that Gary was gone, and we decided that talking to Marie might be a good idea to just do a presentation on what Gary's doing at STIC. And I met Gary through one of his students that came to work at Smith & Wesson, where I work, and just started that communication. We've had user group meetings there, and it's just been a really good working relationship with the college for both my company and for our user group. So we decided we'd start this presentation and show you what we've been doing over the past couple of years.
Exactly. And if you notice, Springfield is in Massachusetts, and I don't think John and I want to talk about football anymore after Sunday, but
Nope, that's fine.
You know, the better team always wins. What are you going to do? All right, let's talk about what we're actually going to cover over here. So as we said, we really want to talk about industry and education. I mean, we in education need industry. We want people to have jobs, and obviously people in industry, geez, they'd like to have people walk in the door who know something, or be able to hit the ground running and be able to do stuff. So
yeah, I've taught enough SolidWorks. I don't want to teach.
So first of all, I'm going to define the program. Secondly, I'll talk a little bit about the curriculum that we use, and specifically I'm going to talk about it with regard to SolidWorks. So that's really the educational part of it. Then we're going to start talking about where industry comes in. Well, we have a very active advisory board, as well as the user group, which John had. So those are where we get the industry involvement, so that feeds back into the curriculum and vice versa. And the last thing I'd like to talk about is this piece called assessment. Our program is accredited by ABET, the Accreditation Board for Engineering and Technology. And a big thing with that is, okay, you say you do these wonderful things and you've got these industry contacts. Well, you have to, how do you show that you really have accomplished, what you think you've accomplished? So I just want to provide a little bit of that. The program is Mechanical Engineering Technology. We are the practical application of engineering. Our students, it's a 2-year program, and the program is set up for students to go right to work. However, we do articulate with 4-year programs, but only programs that deal with engineering technology. Right now we have an agreement with Central Connecticut State University, and a lot of our graduates, I shouldn't say a lot of our graduates, maybe 5 to 10% will go down to Central Connecticut and they will pursue the bachelor's degree in engineering technology. Because we are education, it's not just training, we really emphasize that this is education, this is a college degree. So it's complementary instruction in the math, the science, a little bit of engineering analysis, just trying to whet their appetite for, if they go on, the kind of things that, that they're going to be seeing out there in the real world. And the program, as I said, is accredited through ABET, and I think we're going, this next year we'll be going for a renewal of that. All right, let's talk a little bit about the sequence of courses. How are we using SolidWorks? Right off the bat, in the very first semester, obviously there's 4 semesters in a 2-year program, the students come in for this course called Engineering Graphics with SolidWorks. So right off the bat, some of them have used CAD in high school. There are others who have used maybe CAD in a work environment. We have a student body which is extremely diverse. I'm talking from 17 years old to 70 years old. People who have worked in industry are now back for retraining. People right out of high school. It's that kind of a thing.
Do we have any students in the audience?
Oh, all right.
How long have you been using SolidWorks?
We use Autodesk.
You use an Autodesk? So this is a huge adventure today
A
then.
non-believer.
You've been here for the whole conference?
No,
No? Just today?
no,
What do you think so far?
it's cool.
Have you been over? So don't forget to go visit the partner pavilion then.
Okay.
Yeah, I'll tell you, one of the things I'll tell my students is, boy, I wish I was in their shoes. The future that these kids have is just marvelous.
Yeah.
So anyway, this gets them going. It kind of introduces the software. It's nice because as an educational unit, they can download the software to a laptop, and off we go. So that course is designed to be kind of introductory and fun, and then we go to work. In their next semester, we go into a course where they're now talking about mechanical design. Okay, now we know how to make sketches, solids, a little bit about drawings, but now we're going to use it as we would in an environment. And I'm clipping onto this as well, the CAM part of it. Our program is a pretty nice blend between design and manufacturing. I think knowing how things are manufactured help designers and people who go off and do CNC or in manufacturing. I think it's a good idea to know what the design end is like. So it's been a very nice mix. In this particular semester, students will create solids in SolidWorks, then they're brought into MasterCam and they do their machining. After the summer goes by, they come back for that 3rd semester, and really is kind of a continuation of where they were the last semester, Mechanical Design 2, and coupled with a second CAM class. The fun thing about this one is you're going to see one of these projects is something they've designed in CAD. They're going to go off now and they're going to make that very assembly in the CAM course, and they can start seeing how all these fits and tolerances work out. And then we end their last semester. We go back to having a little bit more fun. We call this Advanced Engineering Applications, coupled with their final senior project, a capstone course. That advanced course is kind of wide open right now. Talk a little bit more about that a little bit later. It's a kind of a mix between MasterCam as well as SolidWorks. And at the same time, students are doing senior projects, a capstone type course. And then when the course is finished, usually we'll always have our advisory board right at the end of that semester, and the students will present their senior projects to the advisory board. And that's worked out very well over the years. All right, so the very first course, the engineering graphics course, you're going to see on here, I just kind of put up there the books that we've been using. I don't think there's ever been a book that we've ever been happy with, from start to finish. However, they're just good to have as a reference. This parametric modeling book, I think the students, by the time they're done, I think I counted them up, there's close to 50 solids that they make by the end of that semester. So they're really, really cranking them out. And this SDC Publishing, I can't say enough about them. It's a great website. I'm sure those of you in education know about this, but they're just wonderful. Send you desk copies. So I pretty much use these throughout the courses. So what do we do in this class? All right, so obviously we navigate, we learn what's solid, how do you start it, etc. Create solids, etc. using good solid generation protocol. Now, what does that mean? I'm going to quote John on this one. He said to the class one day that the great thing about SolidWorks is that there's 1,000 ways of making a solid. The bad thing about SolidWorks is there's 1,000 ways of making a solid. So it's not good enough to make the solid. We have to think this thing through. We have to have some kind of a plan, some kind of logic to it. It's funny the things you see. Kids who come in that maybe have more of a machining background, they've got to make a big block and, I'm going to start milling this out. I'm there, what are you doing? So how do we kind of instill this idea about, how you're going to make the solid. And I always like to start with defining the features of the part. So, get your hands off that keyboard and mouse and let's put up this part and let's talk about what are the features of the part. Okay, I've got maybe an outside perimeter. Now maybe I've got a threaded hole, a through hole, a boss, whatever. Let's define what the features of the part are.
Because I'm always talking to Gary whenever he comes over at our user group meetings. I'm always saying design intent, design intent. You're not just redrafting the part, right? You're not just taking sketching and making drafting and then going to the drawing and doing the same exact thing. You need to put some design intent into your sketches, your models, and how you create it.
Absolutely, it has to make sense. And then when that is all said and done, once we've created the solid, we are going to name the features in the feature manager design tree. I learned that the first user group meeting with John, also with folders. So I tell them, I says, look, if you're going to be applying up at Smith & Wesson, I says, these are the things you better be doing or else you're never going to get a job. So no more boss extrude 1, boss extrude 2. I mean, it's one thing if it's a simple part, but you start getting into complicated things and you get lost very quickly. Understand the use of dimensions and relations. Now, this is exactly what John was saying, this concept of design intent. Okay, so talk a little bit more about that in the next slide. You're going to document the components here with drawings. Now, in this class, the drawings are really an introduction. We don't push the ANSI specs at this point. Just, do you know how to set up the views, that kind of stuff. And basically have fun with the software. So have fun with the course because then you'll never have any more fun again. So this is always a good way to end it. So it's interesting to see the ones who really catch on. I think the record is there was a student who went through the book, I think in 3 or 4 weeks, talked about the CSWA test, and I said, I don't know, why don't you go online because we don't offer it till May. He found the test at the SolidWorks website. He took it, he passed it. He emails me the certificate. He says, well, what do I do now? And I'm like, well, I don't know, maybe you could teach the rest of the course and I could take the time off or something.
It's great to have kids that are ambitious. That's one thing I've noticed with the user group and actually having the kids come out to the user group meetings is I was a little nervous at first that having some of the students was going to be this mass horde free food at the user group meeting, But it really wasn't. You get students that will come to the user group meetings and I watch them and they have it can do that. Then they can't wait to go back to school so they can try it again. So it's really getting the kids involved has really been a good thing for my user group anyways.
Yeah, that's exactly correct. I always love that the next day, I'll come into class and I'll see the ones that I selected to go to the user group meeting. And there they are, with SolidWorks. Oh, let me show you this, let me show you that.
You selected
really,
them?
It's been nice.
Oh, I thought they were just coming free will.
Oh, no, it's a privilege to go. Privilege to go, John. Okay, using relations to establish design intent. This is the big thing. So given this figure, we have a center line in the middle of this. So obviously the idea is this 175 length has got to be in the middle. And not only that, we've got a couple of holes which are equal. And we also have a height of 175 on each end that has to be maintained. So given these dimensions, what is the sketch going to look like? So I would like to say this would be the first sketch. Now, here we start talking about a couple of different things, design intent, as well as talking about features. What the students are going to want to do is they're going to want to make a sketch. They're going to put 3 circles on there, extrude the whole thing. And I'm like, what do you got? You got one extrusion. No, let's stop and think about what this thing is. There's actually, I would say, at least 3 features to this part. You've got the perimeter. Let's make that first. And then you've got a large hole that's in the middle. And then you've also got the 2 small holes. So let's look at this from a feature point of view. The other thing now is the concept of design intent. This 175 dimension over here, that line has got to be in the middle of that. So a lot of people think they're so clever, well, I'm going to take the 4, I'm going to subtract 175, divide by 2, I'll get that dimension. Boy, I can do math. I said, no, that's not what we want here. Because what happens when the 4-inch dimension changes or the 175 changes? Now you're forcing me to go and make other calculations. That is not the design intent. So the design intent is to keep that, and obviously That's done with a relation lining up the center points the midpoints in a vertical relation. And obviously the 175 dimension, that can be done either with a horizontal relation or simply an equal relation. So those are the kind of things that we push in that first course, and it takes a while. The other thing is fully defined sketches. That's another bugaboo that I have. In the beginning, we kind of baby them a little bit. I think it was by about the third week, I said, look, on this next set of solids that you turn in, I'm going to look at your design tree. If I see anything that's not a fully defined sketch, it is a 0. I will not look any further. And that very quickly ends that whole debate about fully defined sketches. All right, now we move into the second course, and this is where we now are going to work. So what are the big things here? Well, right off the bat, we're going to start saving the file names with a part number. You're not going to go off into industry in block 1, block 2, lab 1, lab 2. That's not happening anymore. So we develop our own kind of numbering system, and that's the way we approach this. Now we're going to start talking more about the 2D level of it with assemblies, balloons, bill of materials, as well as the drawings. And now you notice that the ASME specs come into play here, both with the layout of views and also with the dimensioning. Views, that's always another interesting thing. You can make a solid, go in to make views. Students will put views all over the place. They'll make the front view a different scale than the top view, and you start going crazy. So the idea is that whatever you do, and I don't like it, you better get those specs out and show me that it's allowable. And obviously that same thing applies with the dimensioning. So we really push that a lot. And obviously, in our business, we're in the Northeast. It's a very high aerospace area, gun manufacturing. There's some medical, very high, a lot of machining, and a lot of precision, a lot of tight tolerances.
Yeah.
Okay. What else we got here? Now we're starting talking about how do parts fit together. That's always a good one. I always like people who come in from high schools and say, I shouldn't have to take any of these courses because I already know this stuff. And look at my prints. Oh, you've got a 1/2-inch bolt and your hole is a 1/2 inch. And that's going to work out how? So those are the kind of things that we start pushing. How do these things fit together? And that's really, we have to start knowing about design. Demonstrate an understanding and apply GD&T. Always a difficult thing to teach. In that second semester, they are always also taking a course in geometric tolerancing as well, where we kind of combine that with lab use. We've got a metrology lab. We talk about fixed fastener formula, true position. So try to give a little bit more of that. It's always a tough area, but it does come with time. And then by the end of that course, they are able to take and hopefully pass the SolidWorks CSWA exam. We offered this for the first time last May. I think there was 15 kids who took it and only one did not pass. And the sad thing about that is that this individual probably knew more than anybody, but still has that exam anxiety. So they certainly were well prepared to take the test. And so by the time they leave the college, they have that CSWA certification. And, John, if you could comment on, how does that look to somebody coming into maybe an application at Smith & Wesson?
Well, I'm a big believer in certification because, you can get a lot of people that will come out. Kids can come out right out of college or high school. Yeah, I know SolidWorks. And you put something in front of them. You say, okay, can you model this? And you get that little bit of a blank stare when it's something that they didn't cover in school. Just by having the different levels of certification. When I got my first CSWP, well, my only CSWP, you don't get more than one. They didn't have the CSWA exam, so it's really nice that they've now put that CSWA in there. Get your feet wet, take the test. It's usually, if you've played with the software for a while and you've gone through the tutorials, you can get that certification. Something to be proud of, something to put on your business card, on your resume. And just by the sheer fact, if I see a resume that has certification on it, that means that this person has taken the time to, actually looked at the software from a different standpoint, get certified. You can get a degree, you can get, whatever, but the software that we're using at work is SolidWorks. And, if I have to train somebody from the get-go that has no experience whatsoever, it's going to be more difficult for me. So it's a great tool to use, and and there are a lot of. Is there anybody else in the educational room that's using certification with their students? Excellent, excellent. So there's quite a few. What levels? What levels? CSWA, CSWP. Is anybody doing CSWPs? Just doing A's. Anybody going higher than that?
We're doing both.
You're doing both. How are the kids doing with the second level, the tier?
Some pass.
Yeah.
So it's a challenge. So I imagine the kids that get the CSWP are, you get to puff your chest out a little bit. I'm certified. What, Nicole?
We use it for our company when we bring in employees. We've actually established that rule that they have to have at minimum a CSWA or a CSWP, or we won't even longer bring them in for an interview.
And I think.
We've had way too many people who say they know how to use SolidWorks,
Mm-hmm.
but they don't know how to use SolidWorks. These are at least a good judge of how well you know it.
Right, yes, exactly. I've seen the same thing. People that, have been even using the software for, 3-4 years will come in and, they're staggered. This session was originally set up for an hour long, and we got switched to an hour and a half. So if you guys do have questions while we're going, please feel free to ask.
Yeah,
Had a question?
I just wanted to make a comment. The CSWP, a lot of times you can get workman's money because now it's requiring certification in drafting or engineering type programs.
Mhm.
So if you're high school, or that's one of the requirements, so where you can get more money. So a lot of times it'll pay for the per student for the other certifications that are not free if you don't have 45.
Yeah, we've noticed that. I'm also helping out Putnam Vocational School where I am. It's a vocational school, so it's not college level, but they're really going after that certification because it does help out all that sort of. I don't know if every state is different. I imagine it would be, but yeah. Yeah, and if you're in the educational field and you haven't met Marie Blanchard, track her down, find her, introduce yourself, and she's just a wealth of knowledge, and she's actually the author of that book down there at the bottom. Her and her husband, I met Marie way back before she was with SolidWorks. She started a user group in Massachusetts, was one of the very first ones at her college that she was, her and her husband was at, and that was a user group meeting that was probably 300 people or so. They only managed to have 2 of them before she couldn't, she ended up going to SolidWorks, but just good experiences. Go ahead.
Yeah, the book
Back
at
here.
this
Back to you.
the book at this point is probably a little bit more of a reference, but there's some good tips in there about setting up drawings and stuff like that. Again, like I said, it's always good to have something for a reference. I'll talk a little bit about the projects that we do. Okay, so this is hopefully makes us a little bit more unique. I'm going to mention 3 of them. There's a design proposal critique, something that came in from a customer, so I want the students to take a look at it. There's an arbor press. This arbor press, you'll find out about later. We did this as part of a grant that was sponsored with an NSF grant. And the name of the grant was the Virtual Ideation Platform, the VIP. And it was a collaboration between us in Springfield, Mass., Keene State, which is in New Hampshire, and Central Maine Community College. Central Maine is Auburn area, kind of almost getting into the middle of Maine. And the idea is that how can groups, students work in a collaborative sense, basically as virtual teams. And these shots here, I included, these are students that worked on the arbor press, which was originated at Central Maine, and that is some shots of our video conferencing center. So this is how we communicated back and forth. So a little bit more on that later. And the last thing to mention I'm going to talk about is the fireman safety step, which is kind of an interesting little thing. Let's start over here with this proposal. So this is something we kind of dreamed up. Here's an idea of a caster, and here's some specifications that came in from a customer. The assignment is to look this thing over. I want a report back from you. Is it going to work? Is it going to go together? What do you want to change, if anything? You know, you're my engineer, so let's see what you have to say about it. So a couple of things that we want them to notice on this one here is, you know, starting with these bushings. These are bronze bushings, and the customer's calling for a FN1 fit with the supports. So obviously these things get pressed into those supports. All right, that sounds fine. I can look up those fits. And then I'm going to take a shoulder screw, it looks like, and I'm going to slip that thing through there. And there's a wheel that goes on, and I'm going to tighten down that shoulder screw on the other end. So I guess the thing that hopefully they're going to see is, well, what is turning here? Well, let's see. I got a wheel. I would like to think that's turning. I guess that makes sense. I'm going to have that wheel turning on the shoulder screw. But if the shoulder screw is tightened on the other end, is that moving? And if it's not moving, then what are the bushings doing? So those are kind of the things that we're hoping that they'll pick up. You know, and speaking of the shoulder screw, there's the customer's calling for an RC1 fit with the idea of the bushings with the shoulder screw. Now that RC fit is like around 5/10. So I guess the idea is I'm going to press those bushings in. Those holes are located in some way. I don't know what the tolerances are at this point or where you have to hold them to. I'm going to bore out those that idea of those bushings. I'm going to sock those things down to the plate. I've got clearance holes in the supports. So after I tighten this thing down, you're going to tell me that shoulder screw is going to slip right through there and everything's going to be fine. Not really very likely. Not to mention the fact that when they start talking about an RC1 fit, well, that means I've got to go make the shoulder screw to a certain diameter. Well, we're not going to do that when I can just go to an MCS catalog and just purchase one. So those are the kind of things that we're hoping that they'll notice and come back with. Probably the other big thing with this is after everything is down, you notice that it's a line-on-line fit between the wheel and where the supports end up, so meaning that that's probably going to bind up. So it's funny to see some of the proposed solutions. Well, I'm going to get pins. Everybody's got dowel pins. I'll get those babies lined up. And so somebody else says, well, we're going to bolt it down, and then I'm going to take a drill, and I'm going to ream right through both bushings at the same time. That is going to line those things up. I said, yeah, fine, but it might have to be taken apart at some point. But I would say a good amount of people all of a sudden realize that, geez, why don't we put the bushing inside of the wheel and kind of go from there. So it's just a nice little project, a little nice thing for them to come back and make a report on. So here is the arbor press, second project. This arbor press has been with the Central Maine machining program for years. This is part of the things that they made. Again, this is sponsored through with an NSF grant as we worked with this. The problem that Central Maine had was they had either no drawings or very, very crude drawings. They had some specs on there's a rack and pinion situation in there for the press. So our task in Springfield was to basically reverse engineer this. We have to establish what these fits are going to be. We've got to create the drawings and so on. So that was a nice little project. Let's go. The fireman safety step. This was something I know probably a lot of you in education, this has happened before. You either get a phone call from somebody who's got an invention or an idea, and everybody thinks it's going to make a great student project. A lot of times that they do. Sometimes when these come in, I might set up a student almost like as a consultant. I said, you go ahead and work out the details. But I found this one rather interesting. This was literally a fireman from the Springfield Fire Department who came in, walked into our lab one day with this kludge. He had put together basically this platform. And here's basically the idea in a nutshell. When the firemen first get to the fire, I'm talking about a residential house, up they go to the roof, and then they use what's called I think it's called a ridge or a ridge ladder. So up they go now on the roof, and their first task is to cut a 4x4 foot square in the roof. And it vents out the smoke and has something to do with how how the fire progresses, that kind of stuff. Well, the problem is that you imagine you're on this ladder, and that ladder is kicked away on people, and he's had a lot of his, I shouldn't say a lot, but he's had people who have fallen off roofs, and obviously it's a bad situation. So his idea is to create this little step. The idea being is that the firemen, off they go to the roof. They've got this platform attached to them. When they get to the top, when they get into position, they actually make a cut into the roof and attach the platform. So now this is locked in, and the firemen would also be tethered to it. There's a little hook there. So now with that sturdy step there, now it's a lot easier to make the cut, and of course if they fall, at least they've got something they're tethered in. Now the attachment to the roof, you'll notice, is missing. And the reason for that is I can't show it. He has gone in for a patent with this, and I guess that is his big secret, is how this actually ends up attaching to the roof. So what I did with this, I took two of my better students, and these were I think were the first couple that John met at the user group meeting, and I said, okay, you guys, go at this. So they came up with essentially what you're seeing in their design, and of course they always have to be clever with a little piece of fire there. I thought one of the unique things that they did in here is, if you could tell, but this is almost like a lawn chair, so they can it can be adjusted to the different slopes of the roof. And what happened was they ended up with the solids. They created some drawings, and we turned the whole package over to the fireman, who went off and had it made. As a matter of fact, just before I left, he had showed up with some of the first prototypes that he had made, and I guess we got a little bit of tweaking to do, but it definitely was a really excellent real-world type project. All right, now let's go on to the next design course, Solid Modeling 2, basically. Again, another book that we use. There's a couple of nice projects that come along with this book that really lends itself nicely to some extra credit work. But the book essentially, again, is just more of a reference. So you're going to see a lot of reruns here. Again, we're talking about assemblies. But we do a couple of different things. Maybe this is a little bit more mundane, but engineering changes. Most of these graduates, one of the first things that they'll do on the job is to process an engineering change. How do we document that? So we go through that. Start to get a little bit more fancy now with the SolidWorks. We can use variables. We can add some intelligence to our parts. We're going to create some exploded assemblies. And again, this is understand and apply fundamental mechanical design principles. Just a continuation. How do parts fit together? How do I dimension? How do I dimension for manufacturing? How do I apply GD&T? Again, pushing it and pushing it. And there we are again. They can't get away from this. They cannot get away from those specs. As I like to tell them, I says, if I was going for an interview, I'd have a little briefcase with me, and as you're getting your stuff out, you might want to pull out that spec and make sure people see it so they know that you've got something that you can go by.
Yeah, and to me, the 2D drawings is kind of a big thing. Computers are great. SolidWorks is great. You can make drawings really fast, but and I'll tell this to Gary during the meetings. I'll mention it, in some of my meetings when I talk. Whenever there's something brought up about drawings, is that drawings are great. You can make them really fast. Computers are great. You can make bad things faster. So you can make wrong views, put them into different spaces, and then copy those drawings and keep reiterating those things. So if you don't pay attention to ASME standards and how you're projecting views, it's just a downhill process from there. So it's really important for that Gary teaches the students, pay attention to this stuff. It's not just put a view wherever you want it.
Yeah, absolutely right. Sometimes you'll get feedback. I'll get students will say, well, I'm working part-time at such and such, and they say that those standards are too expensive to use. And my comment is, well, I think it's too expensive not to use. I says, we're not just going to have you, I don't want you at an interview and people talk about dimensions and well, I don't know, when I was in college, we just did whatever we wanted. No. We've got an international standard that everybody goes by, and you're going to know it inside and out, certainly by the time you leave us. All right, some projects that we have here. We have the stacking rings, a nice little project which we call the kill switch, and you can see that over there in the right. That thing is actually created, and then that's manufactured as part of a CAM class. And then a very interesting project called the Arbor Press bolt-up. Now, Stacking rings. This is kind of a fun little thing, but it lends itself to a lot of great areas. For example, we could talk about configurations. You've got a part there which obviously has configurations that lends itself to a design table. So we've got basically a donut. You've got a couple of diameters there, and from there we can make a design table which reflects how each configuration changes, as well as the colors. So of course, obviously this ends up being a part family. These are all blow molded parts. This is a baby's toy. I actually have this, and it still has a little teeth mark in it with my kids had it, but at least now when I bring it in for the semester, they don't cry anymore because I'm taking their toys away. So that's some progress. But it's fun. And by the way, you can't buy the 7 ring anymore. So I've looked for it. It's now down to, I think, 4 or 5 rings. So this is, I think, becoming a collector's item for me. There's a nice helix, how the post threads into the bottom of this, and I think we have this open. So this is actually from the students. This past semester, the rings.
So Gary was kind enough to bring some files down. The interesting thing I thought when I started to open up the kids' files was just how people construct things. You know, there's 100 ways to do the same thing. You notice normally when you hit a sketch, right? Normally it goes right in the center plane. That was the first thing I noticed was, hey, this kid created it off center. You know, it's a round part. You would think set it up in the center. You can notice that, you know, he has some work to do. When he did his revolve, there's some extra stuff going on. But you know, they used actually thin feature to revolve these. It's just and then he worked into configurations. This version of the model doesn't have all the configurations that it normally had in it, but they even got into some exploded views. Let me get out of this for a second. Just to show you guys what some of the kids are doing. So the kids are getting some pretty good experience. They even went as far, and I don't think you knew that they were going to do this, they went in as far as to put the text in there. Oh, look at that, interesting. Fisher Price 2. And then we have Fisher Price toys.
Yeah, well, looks like we're not ready for Christmas yet.
Well, let me go back to... Here we go.
Okay, so that's that. And I think if you notice, the base was not a blow molded part either. So
we can go back.
We got some
time.
things to do. Yeah, we got some things to do with them. You can see the helix very well on that one there.
Come on, there we go. So look at the kids are getting into shells. I mean, in some of these functions, they don't even cover in essentials. Well, actually, I'm not sure. It's been a while since I've taken an essentials class, if I ever took one. Do they cover shells in essentials? No?
They do it in molds, and they do one.
So even though it's a kid's toy, and I don't know what the kids' experience were when like, oh, we got to model this, but it's actually will make them think about it. Let's go back for you, Gary.
Did they do any reverse engineering on that?
Exactly. Yeah, I bring it in, and then we go from there. That's exactly correct. Yep. Yeah, measure them all out, at least to the best of their ability. So yeah, that's exactly what happens with that. It's not with the 7 rings. You can get them with the 5, but not with 7 anymore. So it's it's a collector's item. One of the things too is they end up after they make the exploded assembly, make an AVI animation of it too. And
sorry, I just like doing this.
That's
this
all right.
is fun.
So I'll entertain you.
I got to learn how to go backwards doing that.
So the idea being is the AVI ends up on a DVD, and that's going to be the new assembly instructions that are going to go along with this, so that all the parents will know how these things go together.
So they made one model for all the rings. So they got to learn configurations. I still have people at work that, they're already in industry. They're tool designers, or their SolidWorks is kind of thrust upon them as the company changes, and they don't use configurations because they just either don't want to learn them, or so the kids coming in knowing configurations and knowing some of these other high-end, well, not even high-end, but just what SolidWorks is capable of is great.
Alrighty.
Any questions at this point? Anything anybody wants to add? Experiences? Bill?
Teach both first angle and third angle projection? Or how do you
No, just
third angle?
Yeah, just third angle. That's all. Yeah. Yeah.
But the problem is sometimes you'll get things in that are first angle.
Sure, very, very possible. What we try to do is model what the companies in the area primarily do, and that's really the biggest thing. So that's our main area of concentration. I know that one of my colleagues does talk about that a little bit, but it's very brief.
I have seen where people have come up and said, SolidWorks is screwing up. My installation is bad. I take this view and I project it off here. It's the wrong view. I said, you're using first angle. How did you click on that? What template did you use? So it is, it's kind of funny that you mentioned that because it is out there. Is there anybody using first angle projection? Do we have anybody from?
What I do is I just introduce it so they know the difference and
Yep.
explain that that's, if you get a drawing from overseas or whatever, that's what you're going to look for. So if you open up a drawing and all the views look weird, then think back and think, oh, okay, this must be first angle.
Yep, that's pretty much our level of that, how we cover that as well. Yep. The kill switch. There's one of our students who's got this thing done. It's just a little toggle thing that goes back and forth. But the interesting thing is it came in, again, from customer sketches. So this is something that came in. There's fits there, or at least fits that they think are going to be working. And as they start going through this, they're going to find out that there's mistakes in it. There's deliberate mistakes in it. There's a bolt pattern that is not squares, 4 bolts, and it's not square, so one spacing's different than the other. So we're looking for them to find that. There's also like a shoulder area on this where there's supposed to be a washer. They find out that the washer doesn't fit, is too large for the shoulder. So it's just interesting a lot of times what you will see. Some, they won't notice it, and others right off the bat will start challenging it. And those are the kind of things that we want to talk about. So their job in this particular case now is not just to critique it, but they're actually going to go off and determine what the tolerances are, what GD&T that we need on this part, and then actually design and document it. So this is one of the projects that they will then take. We do this early in the semester, then on the later end of the semester, they actually will create that very thing in bringing everything into Mastercam and actually create it. Seeing how these things, and that's great. What did we did a RC1 fit or an RC3 fit. What does that really feel like in here? How difficult was that to maintain? So that's where we kind of like to close the loop there.
Yeah, I got to mess with Fortran when I went to college, so.
Oh my God, Fortran.
Yeah.
With the cards that stack up.
Let's not go there.
That was scary. The Arbor Press redesign. This is a good one. Again, this comes from our VIP grant through the NSF. We talked about the welded assembly from Central Maine. So one day we get a call from Central Maine that says, hey guys, we just got in some new EDM equipment. And the bad news is in order to make room for that EDM equipment, we have to get rid of all of our welding. So we're no longer going to be teaching welding in our program. So we want you to take this Arbor Press, and it's got to be redesigned. There cannot be weldments, so we want it to be basically a bolt-up. And while you're at it, we're going to add some more constraints to this. We've got a whole room of 3 3/4 inch round stock, and I want you to use that for the head. We want to be able to use that up. Not only that, but our rack, well, we'd like the rack to be round this time, and I want that rack to run into bushings. Into bronze bushings. And while you're at it, we want the weight of this thing reduced as much as you can. So that is what we were charted with. And again, well, let's see, let's progress. So here we go. Now, we started this with brainstorming. All right, how are we going to do that? So I kind of paired them off in teams of 2, 3, and there's a lot of people who want to work by themselves or ones. And so everybody kind of puts together what they think is the way this is going to go, and they present it in front of the class. So as they're presenting in front of the class, everybody gets through with this. And what's good about it is how much they'll fight things like, well, that rack shouldn't be in bushings. The pinion gear should be in the bushing. And I was like, look, it's the customer. It isn't me. You're going to have to talk to them to the customer in order to get them to change their mind if you so choose. So it gets beyond just an academic exercise now. Now you actually do have somebody that you have to deal with. I'm just the supervisor. That's all I am. So after everybody's presented their concepts, we kind of like write down some of the main features, and everybody gets a vote, or they get 3 votes, and we tally them up. And it gets quite competitive, and you can see it gets maybe a little bit too competitive, but well, anyway, that's what we like. We like enthusiasm at any cost. So the class decided on what the final design was going to be, and that's what it ended up being right here. So it's kind of cool in the sense that you can see where the round stock was used for the head. The rack is round now, and it's inside of the bushings. And this was one of the more clever things. One of the kids went off to Central Maine's website and took a copy of their mascot, and now that's in the size, so that's perfect now for their EDM work. So they were really thrilled with that, and you can tell how the weight of this has been reduced. But let me talk about how this came about. I had a class of, I think there was 15, and I looked for 2 people to step forward to be the managers. So their task was to set up this project. What are the tasks at hand? What's the timeline? How are we going to go about this? Their job was to assign the workload, eventually gather the solids, do the final assembly, and put it together and oversee the project. So off people go working, and so people are working on solids, and we don't happen to have PDM, and as you would imagine, we had absolutely no problem with solids and several solids out there of the same thing. No, none of that ever happened. Everything just came together perfectly. Well, as you know, I'm being facetious here, because they found out how quickly what a nightmare that can be when you're collaborating across lines, and what's the right solid, what is it? And PDM, I know for us is an add-on that we would have to pay for, so we haven't done that. It would be nice to incorporate that at some time. And we've tried a lot of different ideas. They share a directory like on a network. But it doesn't matter. I'll go by and I'll notice that the managers are putting the assembly together, and I'm saying, wait a minute, I've got somebody over here working on that base plate. Which is the right one? And it eventually comes together, but it's quite a learning exercise, that whole thing. So that was a good project. Now we're off to the last course to talk about, which we call Advanced Engineering Applications. The idea is, again, is problem-solving skills. The idea of this is it is a kind of a blend of SolidWorks and Mastercam. There's actually 2 books that I use in this thing, and this is this Advanced Techniques. I like this book because there's a lot of nice stuff in there about surfacing, which I like to get into in this course. Let's see. The last sentence is my favorite. Okay, the idea being is that you're going to work together with limited guidance from me. So I'm going to put out some problems, and what I like to tell them is that I'm the brother-in-law of the president, so I got this job, but I don't know anything. So you are going to have to be able to do all the work to make me look good. So and we like to have them work together on this. So I'll talk about some of these ideas. Hit the first 2. So just a little bit different geometry, complex geometry, compound angles. So we'll put something like this out there, and I'll say, okay, maybe in teams or whatever you guys want to do, take a look at this, and then I want people to come up and show us your solution. How are we going to do this? On this first one is the sense that you've got this tang here, which has got a slope on it, and some of the dimensions are in the front, but you've got this dimension here in the back. Well, how are we going to deal with that? And it's amazing how people will not believe that will end up at an angle like that until you actually model that in SolidWorks. The compound angle over here is just really setting up a couple of work planes. But what I like about this one is, all right, now we've got to make a drawing of this. So you talk about auxiliary views. Obviously, this requires 2 auxiliary views to finally get the true shape of that part. This is where surface modeling comes in. There's a couple of them here. Both of these examples here are part of the Mastercam book that they use with this. In that particular book in Mastercam, they have you model it as wireframe in Mastercam, but we don't want to do that. So we take those models and we do it in SolidWorks. This first one is excellent for surface modeling. Those pockets are actually not flat, they're actually on a curve, and you end up projecting curves down. It's an excellent exercise, finishing up by knitting it together and actually creating a solid out of it. The lower one, actually this one comes first. There's 2 different levels here. There's a slope on each one of those sides, and the tops of each one has a certain curvature to it. So we'll make a surface out of that curvature, and then they'll replace face command. So starting to get into a little bit more. I tell them, you started with a fun course, but that's baby fun. But you end with a fun course, and now we're really into more of an intellectual fun thing. And it's great to see people really get enthused about it and work together.
We have a question over there. Okay.
I'm sorry.
Give them like a compliment on that when you were talking about, you give them all a sketch, and do you say something like, well, since this is about, we only have this much money in it to pay for your design work or whatever to keep things running, or how do you treat that?
Now, we don't do a lot with costing, so we haven't included that at this time. It's really just more from a design point of view right now. Yeah.
So they can take pretty much as long as they want, as long as they...
Well, there's a time limit. Obviously, there is a time issue that's involved here. That's true. But I'm sorry, it's the costing part of it we're not doing. But obviously they have to have we have to hold to the time. There's no question about that. Oh, I'm remiss. Thank you, John.
Yeah, we forgot to show you that the kids actually did model it. It is real, so you can see it. And also, the kids are getting into this where they're actually using some of the more advanced commands. So they've got a limit on there. No matter how high I drag this, it's not going to go any further. So it's actually stopping. So the kids are putting quite a bit of work into there, and I actually might have to go over and visit Gary more often now just to have some fun with SolidWorks as opposed to what I normally do during the day.
I have a question.
Okay.
So on that part that you just had filled up there, I noticed that you have a crap ton of your catch screws and things of that nature. Do you make it a point to have your students use Hole Wizard, or do you let them just use extruded cut?
Mostly Hole Wizard.
Okay.
Yeah, because through Hole Wizard you can get the clearance holes and.
So then you don't use feature-driven component patterns in assembly? Yeah, that has been done once those come in. Yes. I mean, from a production standpoint, having that type of thing where the number counts are automatically put in versus them sitting over there and mating up each tiny little screw and things of that nature makes things simpler.
Yes.
So
Yep.
if there's certain things from people who are going to hire these people coming in that we like to see them knowing how to do ahead of time.
Okay.
Right.
Yeah, Gary doesn't have me checking the kids' models yet, so maybe that's something I could do, huh?
Oh, that would be fabulous, actually. It really would.
We have a couple other user group leaders in here. Is anybody doing that? Is actually anybody working with this education and actually going in and reviewing what the kids have done and giving back feedback? No? Yeah,
Actually, starting up a competition between the different schools and then going to review a model and have them collectively as a group present a model for their representation of their school. and then we'll review live which one won, and then we give an award for, we do it for college and high school level, and we give them an award for the quarter. So like instead of an employee of the month, we have a school of the quarter, since we only meet quarterly.
That's a great idea. You could actually take that more national. I mean, they have lots of modeling competitions that schools compete with at high school levels. A good friend of mine, both of his sons have competed. He's a SolidWorks user. Now his sons are following in his footsteps. They're SolidWorks users, and they're actually helping out a lot of the robotics programs they're doing. Some of the robotics stuff that is coming out of the high schools is amazing. And I've seen some of the kids present at different user groups that are doing the high school robot competitions where they got to pick up a ball and throw it, or that sort of thing. They're really going to town using the software.
Yes.
Yes, sir. Do you spend much time top down versus bottom up regarding this?
No, I think we pretty much exclusively make all the parts first and then bring them together. Yeah. Yeah.
Sure.
Yes.
You may not want to address this, and I would understand. Sometimes toolbox can be a real problem. I know that when our company is switched over to products, toolbox was kind of crazy for about a year and a half. And so strategically, are there advantages to say taking fasteners, washers, things like that, and not using the parts out of SolidWorks toolbox? Rather just make a discrete part, maybe make a family table or a design table. Here's 4 parts, and they're not going to get hosed up as they get transferred back and forth to PDM works or enterprise. So I've seen it happen. You'll have an assembly, and you'll have it all put together. Everything will be right. Then the next time you pull it out, the screw that you have, it's got a different name, it's got a different job here because, it got confused by enterprise.
I would have to say on the educational level that you really need to probably discuss both, because not every company is going to, because Toolbox doesn't come with standard SolidWorks. You have to get the professional edition. Not, especially depending on the size of the company. We're a bigger company, but most of the parts we use don't use fasteners, but our tool design department uses it all the time, so they would use Toolbox, but the product engineering group, we don't use Toolbox parts because we just don't have, they're not normal screw sizes that come together. So, Nicole?
In response to your question, the thing that you have to make sure of is whoever, if you do decide to go that route, whoever sets up and makes any new ones, so let's say you get a new type of fastener, that they set up it with the same planes and orientation.
Yes.
Because if not, when you go to replace the component in the assemblies, then it blows up and your parts are laying sideways and things of that nature. That's why most people don't go that route, is because it's not as simple always to just replace the components in your assembly levels.
Yes.
Because
Yeah.
people don't think that far ahead of when they're making their parts.
Yeah, Toolbox is a tricky one.
Yeah.
That's best off as its own whole presentation. But any other questions or anything about this Arbor Press they want to see?
What stops you guys from using WorkGroup?
Probably that's just that it comes with professional edition.
Right.
But they're using toolbox.
Yeah.
Well, you got the educational edition. You should get everything. So you probably have, but each college has its own data matrix of how they log into computers and things of that nature. So, their IT group is probably the ones that would have to set up a server vault. Plus, think about the real capacity of PDM Workgroup. I don't think it's intended for a school with, lots of kids putting lots of files into it. So Workgroup's really not. That's not its intent. I love Workgroup. I've been a Workgroup user since 1999. So I'm, a big fan, but right tool for the right job. Sir.
You get into decide to design parts, the whole design in relationship to the design process. Like taking things, you touch on some of it in terms of brainstorming for design type things, but the
Oh yeah, we go right through it, right into manufacturing, even including engineering design changes and you know, the engineering notice comes out to make the change. They make the change, and they have to up the rev. So we do go through that, and right through the actual manufacturing, and that a lot of that leads to proposed engineering changes from there. And then they finish by actually inspecting the parts at the end as well. So we do cover right through that.
That's a great thing to have interns come in too from the colleges. Have them come in, give them some change orders, you know, where they've got to go in and they've got to make a change, have them follow it through it. You know, a lot of companies don't have the manpower sometimes to just push old changes through. You know, they've made the change out on the floor, but maybe the paperwork's lagging behind. So there are instances like that that could use interns, and that's a great experience for them. We use a PLM, we use a PLM system at work, and kids that have experience with PLM systems, I think it's only going to grow. There's a lot of PLM systems out there now. There's going to, at least if you get your hands on one of them, then the kids are that much better off.
Making a comment about networking and so on, our IT group has made the decision that all students, not just us, the entire college, we've got about 6,000, I think, total students. And they're currently not setting up logins, so the students do not log into a server at all. So all of our lab, they're networked, you know, so they're getting the license off of the network. They cannot save to the computers that they're using. When the computers are shut down and then they're started back up, they refresh to where they were. So everything has to be on a flash drive. And that makes it kind of tough for us. So we don't even have a network set up, never mind being able to use something like Workgroup. I know the college has been talking about that. I think we are going to get there where they're going to actually be able to log in with their name. Because obviously we've got issues with that anyway. We've got people that are printing out paper by the reams, and so they want to start getting a handle on who's doing what. And I think that will come, and then maybe at that time we'll be able to do a little bit more with something like either the PDM or the work group. So hopefully we'll get there.
I have a question.
Yeah.
Since you are an educator, and I have to go speak with one, I figure I should get a baseline of how to take this. I have one of the schools in my area, and their idea of teaching SolidWorks is basically handing them a book and turning pages.
Mm-hmm.
Basically, it's just a monitored lab type session versus an actual teaching instruction type
Right.
portion. And they basically get to the very end, and he has them to print off a piece of paper, and then he grades the drawing. How exactly would you take it if somebody came up to you and basically told you your entire concept is terrible and you need to change it? I mean, like, do you see a particular way of approaching going about that type of, it's a tough subject.
Yeah,
These people are putting a gigantic amount of students
yeah.
into our population and representing their knowledge of SolidWorks, and they're representing SolidWorks poorly.
Interesting.
You don't have to answer that one now.
That's a great key. I mean, the slides coming up when, you know, part of the reason I'm helping out Gary with the SolidWorks user group, as you know.
I was just going to say
is
that, yep.
Having the educators come out and see. I imagine that there's a lot of vocational schools. I know some of the vocational schools in our area are people that were in industry, so they have some understanding. So when they're teaching SolidWorks, they have an understanding of that. So they're not just doing a textbook thing. It doesn't always work out. It sounds like, yeah. So, I mean, invite them to the user group meetings.
Oh, I have.
Yeah, and they came. What kind of reactions do they have?
They enjoy it, but they don't change anything.
I got one thing as far as that coming from industry and then teaching at college is, you know, our students are our products. So if that college doesn't produce a particular product that you like, then go somewhere else, and then that will encourage that college to say, you know, what are we doing wrong? How can we make these changes?
Well, I even got back with the career services people who sent them to us for interviews and things of that nature. And
Do they have, to the topic of this slide, do they have an advisory group?
Yeah.
Do they
I
do?
got invited to join, so this is gonna be bad.
Yeah, I'm starting a new CAD advisory group, and it's hard, especially at a school that I'm doing it at. It's they never had one. You know, the
Right.
machine shop program is just developed, but you know, it's work, but you know, it's definitely, I think, worthwhile if it succeeds.
And one thing to address your issue with the instructor that's teaching, the one thing that's missing in a lot of that I see in instruction is, you know, people come from industry to teach in the college, but they're not teachers. All right?
Yes.
They're
Yeah.
people from industry. They don't know how to teach. I don't mean to be negative here.
Yeah. No, you're right.
They need to be trained. There
Yeah.
needs to be a mentor program. There need to be colleagues to help to take those people through that process and to educate them how to teach and how to be effective teachers instead of just complaining about the situation, going in and helping that instructor to become a better teacher or that engineer to be a better teacher. Because, you know, I walk through the college and I see PowerPoint after PowerPoint after PowerPoint and people, you know, still writing on the chalkboard, and it's, you know, we've got to help. We don't have to, you know, I'm not picking on you, but we've got to educate, we've got to teach those people coming in and working with us to be better educators when it's coming to solve.
Yeah, I have a meeting with this teacher next week. That's the reason why I've kind of figured I would ask in here, so that way you guys can shoot up ideas.
Yeah, and volunteer your services to help
Yeah.
that instructor out. That's like a great way to get it.
There we go.
Great. Yeah, okay, so myself, I'm an engineer in the industry. I want to teach classes in software, okay? Specialty classes.
Fantastic.
Where do I go when you just talked about? Because it's not giving management presentation. You're trying to teach people. You're trying to get the wheels turning. Where can you read about that process?
Start at a user group.
Right, absolutely.
Present at user groups.
What I do is
Yeah.
I invite that person, like Doug, or someone that's going to be a colleague of mine. You know, part of the requirement is to sit through the program and kind of understand how we do things, and then to either, you know, get on board or maybe even make it better.
Yeah. I mean, the sky's the limit.
One of the things that they could do too is, or maybe they could do is like your user group could offer maybe, because they're trying to combine with education, like mini workshops or lectures that would be for the industry coming in to teach. And some of your local universities, they offer something called the Holy Five, and it's supposed to be 5 classes. It's in your education that if you're a technical teacher, it gives you the basics of teaching. If you're going to teach in high school, they require you to go through these 5 classes, and it's basically, you know, how to plan a lesson plans and stuff like that, how to deal with special needs, you know, the history of it, and so it's just very 5 basic classes. Those are, I mean, if you're really interested in being a great teacher, those would be 5 that I would look at taking.
Is that a national type program or?
I'm thinking, well, like where I'm from Alabama, Athens State University, they offer that whole degree online. So all those classes are online.
And what's the name of that again?
Athens, it's Holy Five.
Holy Five. Okay.
Yeah, and if you want to find my email, and I could list the specific classes that you go to, Calhoun Community College. Calhoun Community College. My name's Diana Bullock, so you can find me in the directory there. Bullock. And I know. So, because I don't know if they actually list that as the Holy Five, but our state requires that you have those classes if you're going to teach in industry.
That's good.
That is really good. Yes.
I had thought about for, you know, being a user group leader, I thought about having a special session of like a user group, but having it nothing but for teachers. So that way they can get together, discuss their different approaches, maybe everybody can come together and come up with, you know, better ideas and things of that nature.
That's a-
That sounded like a stupid idea. I tried
That is a
when
really
I
good
was in
idea.
Houston, but trying to find exactly who was the instructors at
Yeah.
as many colleges and,
Yep.
you know, between high school and colleges in Houston, it was insane on the number of them that there were.
Yeah, and logistically too, where do you have it? How do you get them there? Yeah,
Well,
it's,
that in my area, that wouldn't be too terrible of a problem, but
my area, I'd have probably 5 people. Maybe,
Yeah.
maybe.
as teachers in here, would you all be interested in that kind of a concept?
Well, our problem with our user group where I'm from is the user group doesn't take into consideration that, you know, we have classes every single night of the week. And what my complaint was with our user group is you can't call me Monday telling me there's a user group meeting Thursday because I invite all my students. I had, 6 classes going and I want to invite them all to come down on Thursday night and listen to the presentation. And that was an ongoing complaint because instead of giving me 2 weeks notice or even 3 weeks notice, it was Monday before, it just doesn't work.
Have you ever tried to ask them if you could host a meeting? Do you have a?
I did, and
Yeah.
it was phenomenal. I had, I had the classroom was standing room only, and
Yeah.
we had all these vendors, and it was, but I got to say, the group at that time, they just went right back to their, old ways, and kind of just left us out of the picture as an education institution, toward them,
Yeah,
toward the user group.
that's unfortunate.
Yeah, it was kind of.
I guess
But don't give up.
No,
Yeah,
no.
yeah.
as an educator, teaching at community college, I'm more interested in talking to people from industry than other educators. That would be my,
Huh,
I would
interesting.
not-
Yeah.
I guess it'd be nice if there was a couple of teachers there, but mostly I would be interested in industry.
Yeah, you want to know what they're doing.
Yeah.
Yeah, and how, yeah.
Want to make sure what you're teaching today is relevant tomorrow.
Exactly. Getting back to your dilemma, it's the one thing when people ask me what I like the most about this job, and that is that I pretty much can do whatever I want to do. I mean, it's almost like the 4 of us, it's almost like our own company. And I know people, they get bogged down and they don't want to change. It's fascinating to watch people as the different versions of software change, they're still using it,
That's another
Yeah.
problem, how much time do you have?
Yeah.
How many programs have you learned?
Yeah.
Been forced to learn in the past.
Yeah,
How long
exactly.
will this one last, I guess?
Yeah. Well,
It seems like
the good news for me is I think my master cam days are starting to get minimized. So hopefully I'll only be able to concentrate on one area of the software, but I'll be able to do a lot more. That's really what I'd like to do. So
The one thing that I've done to get around that is that we teach a 16-week session. And so I have like 5 instructors coming, not instructors, but, I had a CamWorks. Well, I'm not a CamWorks expert, but I have students that do CamWorks every single day. So they come in and they teach 2 classes, maybe 3 classes in CamWorks, how to go through the introduction part of it, basics, setting it up, which they do every single day. And with a little help, we work together, just like you 2 gentlemen, and it seems to be working out phenomenal.
Yeah.
Goal projectors.
We actually have some things to that nature in a couple of the slides left. We have students that are coming back that are working in industry and now coming back teaching
Yeah.
at night.
yeah.
We got about 15 minutes left.
Yeah,
You
let's
know, these ones
finish
go
up.
pretty fast towards the end. So.
Yeah, we're at the industry point of it, and obviously a lot of you have advisory boards, but these are just some of the companies that represent. You can see some of the larger UTC type companies that support us, and obviously here's John's company, Smith & Wesson. We have quite a few. I think we've got 3 members now. When our meeting comes up this May, I'm going to drag John to that meeting.
Yes,
Kicking
I
and
need more
screaming,
things
probably.
to do.
That's right, exactly. A couple of smaller places on here. DFF is a local, kind of like a job shop, but one of my students going back into the 90s who was really phenomenal is now an engineering manager there. So he's always eager to help out, come back to represent the industry. New Fern is a smaller company. They're into the laser industry, optics. Got a student there who's, again, going back a few years, who's head engineer there. This is maybe an unusual one. It's the REB. This stands for the Regional Employment Board. It's the Regional Employment Board of Hampden County. And our contact there, David Cruz, has been absolutely fantastic for us, linking us with different companies and different businesses. He has set up quickie courses. I know there's one going on right now as I speak where he's bringing some, I believe it's some returning veterans who are going to come back now and take about a month's worth of courses in machining and in CNC. So he's been a fantastic contact for us, and we always invite him to every one of our board meetings. That's worked out very well. Now, what does this board do? Okay, so obviously they advise us on manufacturing design trends, and we do listen when they speak. One of the things is big ones is paperless engineering. People keep talking about when is the drawing going to go away. Well, maybe we will see it someday, but it is not there now, and it's always good to know that it is still an important document to have. Software technology improvements, obviously. We've got state of the profession. What are the job opportunities out there? We know about offshoring, and now we're hearing about people bringing back jobs into here. Obviously, we're in the business to place students into industry, so we want to know what are those opportunities out there. Anytime we want to make a change to the curriculum, we always run it by them, at least to let them know what we're planning on doing, get feedback. I don't think they've ever come back and said, no, don't do that, but they've offered us some nice little tweaks, a little bit of improvement, so that's been very well. This is a good one, arbitrator for engineering questions. I'm glad to hear John volunteering about maybe checking some drawings. This is the kind of stuff that we love. Models, right, that we love. Matter of fact, I did send John one. I sent him, I had 2 different methods of modeling that students did, and I sent it to John. He sent me back some feedback on it. It was nice. Next day I went into class and I presented it. I said, well, you're the winner. You're the one whose model was approved. We had one on this one, which I thought was interesting. We had a press fit situation, and the bushing ended up flush to the bottom of something. And the question is how do we document that? Do we just say press to flush, and can't find anything in any of the ANSI stuff about that. So I sent it out to the advisory board, and somebody came back, sure enough, that said, yeah, you should probably put a dimension in there, maybe a dimension of 0 or whatever it takes. And I like that kind of feedback coming from industry, that, okay, this is the way we would do this. So
not just guessing.
Not just, yeah, exactly. Not just guessing and just making up, what you want. So very good one. Teach evening classes. This is a big one. One of our graduates who's working with John over at Smith & Wesson, he, as of this coming Monday, will be teaching the second level of SolidWorks for us. So it's, I would say the majority of our night instructors are former graduates. And, obviously speak to classes, provide tours, that typical kind of stuff. So that brings us to the next piece of the industrial feedback, which is the user group. And I think I'll let John pick up on this one.
Yeah, I need to talk more. So I'm the leader of the Western Mass user group. We've been around for 4 years, so I'm somewhat new compared to some of the other user groups. But I've been to World this past 4 years, and it is starting the user group was probably one of the best things I think I've done in my career. It's been the most fun. I love talking about SolidWorks. I'm a pure SolidWorks geek, so I love doing things the right way. And that's kind of at the heart of what I like to do with SolidWorks. So when anybody comes out to the SolidWorks user groups, what we like to do is, I need to be able to read so I can remember what I did here. View presentations by industry professionals. So how SolidWorks used in the real world. It's kind of really why I like having Gary and the students come out, find out what everybody's actually doing. We've had a number of SolidWorks speakers come out. We've had some of the VARs come out, and they really do some real world studies, and the kids can see what they might be doing when they come out. Awareness that SolidWorks is more than a software tool. One of the students, Gary, was telling me, he came back and he's like, wow, I didn't even realize that SolidWorks could do so many things. So, and on top of that, when they come out to the user group, they realize that there's this whole user group community and that they can continue on with it even after school. You can find businesses, they're all over the place. I'm constantly telling them, I can't wait to go back to have my first user group meeting and tell them that there's over 230 user groups worldwide now. It's 232, yes. I was just saying over, I wasn't going to be specific, but keep up to date. The technology is moving fast. SolidWorks is, if anybody's got to see the 2014, we took off early, so kind of missed that, but I've seen 2014 a little bit. And you got to keep up with it. You can't stay stagnant on it. So by going to the user groups, you can at least keep up with what's going on in industry, how people are doing things. If you're an older user like me, you realize that, when multi-bodies came on, they changed the whole concept of, the whole join in an assembly over to multi-bodies. There's this whole, dynamic shift, and who knows what's right around the corner. And then you can ask questions, We had this model, if there's something of interest that the topic is, the kids, students, they can ask questions and get answers from not just their teachers or instructors like Gary, but they can get them from me or other users. If it's one thing in my user group, a lot of people don't like to ask questions. The kids like to ask questions. And that's great because the members like to answer them. They don't like to necessarily ask the questions, but they like to answer them. So it works out well. And it brings students in as guests. I've been to a couple of user group meetings where the students have actually presented, and they actually get pretty excited just watching what the new kids coming up are doing, and especially the younger kids, even at the high school level. They're picking up SolidWorks. I mean, I had a T-square and a piece of wood, and I was working on green paper. I didn't have access to a computer. Well, I think in high school they just came out with the Apple II or something like that. And then having the students present, that's a little more challenging when professionals are in the audience. So I can't wait to take some of Gary's students and actually put them through the ringer.
We're going to do that.
We have 5 minutes left.
Okay.
And if you're not involved with a user group and you're an educator, you can go to the SWUGN website. It's swugn.org. Right from there, you can go right and find a group that's local. It'll bring it right up to the map. You can put in your information. Go from there, contact. Right from that website, you will be able to find the contact information of the user group leader. Get in contact with them. I encourage it. I hope you do. And that's pretty much, I'm nice enough to have, I was very pleasantly happy to see so many user group leaders. There's actually, how many are at World this year? Do we remember? Like over 100, did Richard say? So, I mean, there's I think he said about 100 user group leaders just here at World this year. So if you see us, we got this little green badge on here that says SWUGN. Stop any one of us. I'm more than happy to talk SolidWorks with anybody. So and thank you all, you SWUG leaders, for coming. I'll hand it back to Gary. Finish this off.
I'll just finish this up quickly. We're in the process of going back through our ABET accreditation. And as I mentioned earlier, part of it is assessment. So I just thought I would include some of this stuff. John Perella, who's with one of the UTC companies, graduated, I think, 2 or 3 years ago. Just to point out some things that I like to see. The CAD and the GD&T piece of it. So it's just good to know that is still viable out there. Dave Hosmer, who has been teaching with us for years. This kid was interesting. When he graduated from West Springfield High School, he drove a bread truck, and one way or another, he ended up at the college, interested in the program, and he's done very well. Very interesting. Dominic Leduc. Dominic is the gentleman I talked about. He will be teaching now for us. He's been at Smith & Wesson. I think he graduated last year, so he's still relatively new. So again, I noticed that the GD&T thing comes up, the problem solving. So again, just to know that this is working. And I thought I'd also put in something from an employer. I am right now working with Bill Neff at Pratt & Whitney with his colleague Paul Zielinski. We're working on a summer internship program. They want to take somebody who's just completed a first year, come down there, work in the summer in their CAD department. And if everything works out, they'll have a job to graduate upon graduation. And that is about it. I just finished with a couple of shots here from people working hard in our labs. So that's it.
Thank you, everybody, for coming. I don't know if anybody has any last questions before they send us off so we can all go eat. Yes, Nicole?
Do you regret telling me I can pick on you?
No. No, I love I love open forum discussions.
Absolutely.
Absolutely. If anybody, hopefully you all got something out of this. So
Hopefully, yeah. I know I did.